In this video, we're going to over the concepts we discussed about data frames with a slightly larger data set. So let's see how that works. So for this, I'm going to use the data set called Titanic Train. You can just look up this data set, it's online, but if you want to look at it, it's a database of those who survived from Titanic. There is information about if they're survived or not. I guess all the passengers that are recorded with their names. We have sex, age, and then a bunch of other information. If you want to see what exactly those columns are, we can just look it up. So we have passengers, if they have survived, their class, name, sex, age, name of the siblings and spouses aboard, name of the children aboard, number of the children, number of parents, ticket number, passenger fare, the cabin, and also port of embarkation. So I have downloaded this data already, and I have stored it in the same folder where I'm running this notebook. So here, in order to run this data set, I can just say, let's call this DFT is equal to pandas. We can use read CSV in order to pull this data in. Because my data is in the same folder, I can just simply specify the name and the extension. So let me run this. I can just now get a grasp of DFT, and we see that our data is loaded. Now if I'm looking at the data, we see that there are some values specified as NaN, which stands for data values are missing. Now let's just get some information from this data. We can quickly check what are the columns that exist in our data set using dft.columns. And if I'm running this, we see that we have all the information that we saw in the documentation file that's included. We can also run some other examples, like let's see the first 10 rows of our data. We can just say head, give me the first 10 rows. So we can check, we have the names, and we also have the sex, age of all these passengers. We see that again, some information is missing, but that's okay. We can deal with that later on. We can also check the bottom row. So let's just see how large is this data set. So we see that we have 891 or 890 rows in our data set. So these are the last 10. Again, all the information again we can pull. Now let's say if we want to see only what are the names of these people. So I just want to check the data that's stored in the column name. So we can just run dft.name. We get that information out. We can also say, let's say we want to give me data that's located in, if we say 0, we will see data that is stored for the row that is ID'd with 0. So that would be, if you look at the first row, this is the data that we have pulled. So this was Owen Harris Bront and passenger class 3, male, 22-year-old, siblings aboard, and the ticket number and the fare and the cabin, and if they're embarked from. I'm not sure what these codes refer to, but we can pull that information. Let's say we can also be a little bit more specific. I want to slice this data. Give me the location of this with all the rows, but I can also say all the columns, but I can also say give me just part of this data. We don't have any column that's specified with that, but what if we say give me all the data set until, let's say I'm interested in their names, in their ID, name, sex, and age. So all the columns up to age. That's what I'm interested in. I could have also said, give me only the age of these people, this individual. So this is age, the age was captured as 22. Now here, I could have also used lock in order to get, let me just, values from multiple rows. So you can specify, I can say, give me values from 0, 1, and 2. And I want to get all the values. Let's say we set all the rows until 8. So in lock, we need to specify the label and the index as it corresponds, not an integer value. For this, in this case, this makes sense because these are ID'd starting from 0 to 890, so 891 values. If these were labeled with something else, we could not use integers in this case, but here we can. So we have the first 3 rows of our data set. So now we have located these 3. Again, there are multiple other ways to slice this data. I could have just said, give me all the columns. So we see these values. We could have also said, give me, let's say, the first 6 values. So the index of 0 to 5. And I am probably having too many brackets. Okay, so this is 0 to 5 and the values that are stored in all the columns. I can also pull the data. Let's say I am interested to only see the name of these passengers or the age or the sex of these passengers. So I can say, give me all the rows, and here only give me the values for name. Or we can say name all the way, let's say, to age. We want to know the name, the sex, and also their age. So we can slice that data in that format as well. So we have all the names, we have their sex, and also their age. We can, another way to use this, we can also give it an identifier. Let's say we want to filter all the values. We want to only see the male or female passengers on this ship. So we can say dft.lock, and here we can specify, I want to say, give me dft, this item, this column called sex. I want those that are equal to, let's say, female. And I want all the values for those people. So I can say, so this is an information that's only for female passengers. Now we see that we have some IDs that are skipped. So everything else is likely male or stored as male in our data set. If I wanted, let's say, just the name of these people, I can just say, give me only the name column. So now here we can see that it's all the misses that are, or miss that's stored in our data set. Anything that's been coded as female. And if I want to now use iLock, again, I can provide additional information here. Let's just add some comments. So iLock will help us locate data based on the integer. So I can say dft iLock, and here I am interested, let's say, in the index starting all the way to index 10 for rows, and also index 0 to 4 for columns. So here we see that now we have all the passengers starting from 0 to 9, all the way, but not including 10, and all the way not including 4. And next, we can now get some additional information. Imagine we want to analyze our data. For instance, I want to know what are some of the information related to this data set. I can just say dft describe, and this will essentially give me an analysis of all the numerical values. Note that not all of the values are numerical, like name and sex. So I believe it will ignore those, and it will, for whatever that's numerical, it will just give me some information. Let's say now I can see that, for instance, the average age was 29 with the standard deviation of 14.52. The minimum age was less than 1, and the maximum was 80 years old. So you can get some information out in this way. If you wanted, for instance, to be more specific, I can say, give me DFT and the age column, description of the age column. So I can now see more clearly what's the distribution of those values, right? So we can, in the same way, we can slice and dice. I don't know. Now let's say if you're interested to see how many people have survived. So survival was specified based on 1, right? So we can say from this list, if we run, if we check survived and now run a sum function, so this would be the total number of people who have survived the ship, at least in this data set. Or if you want to see now how many didn't survive, it's obviously the whole data set minus these 3. So whatever that has been documented in based on the data that's available in this data file. We can also run the mean, the averages in the same way. So like, if we go back to age, I can just run a mean function and get that information out. So again, there are different things. I can just say what's the maximum, we can say what's the minimum, and we can sort out the information, at least get some basic descriptive information from the file using the simple functions available through Pandas.